Hello everyone and welcome to this video channel Science Class 8. In the previous video class we have been studied about chapter number 16 light. Today let's continue this same chapter 16 light, and for today's video class let's start from textbook page number 229. Activity 16.6 Kaleidoscope. So first let's see what it says. Let's see. To make a kaleidoscope, get 3 rectangular mirror strips, each about 15 cm long and 4 cm wide. Join them together to form a prism as shown in figure 16.12a. Fix this arrangement of mirrors in a circular cardboard tube or tube of a thick chart paper. Make sure that the tube is slightly longer than the mirror strips, and close one end of the tube by a cardboard disc having a hole in the center, through which you can see figure 16.12b. To make the disc durable, place a piece of transparent plastic sheet under the cardboard. So, to make a kaleidoscope, so we have to get 3 rectangular mirror strips, and each about 15 cm long and 4 cm wide. And we have to join them together to form a prism as shown in figure 16.12 here, A, B, C. And we have to fix this arrangement of mirrors in a circular cardboard tube or tube of a thick chart paper. So here to make the disc durable, place a piece of transparent plastic sheet under the cardboard, as we have seen here, figure A, B, C, by using mirror strip. It is shown here, and discs at the other end touching the mirrors. Fix a circular plain glass plate, figure number 16.12c, and place on this glass plate several small pieces of color glass, that is, broken pieces of color bangles. Close this end of the tube by a ground glass plate. Allow enough space for the colored pieces to move around. Here, your kaleidoscope is ready. When you peep through the hole, you will be able to see a variety of patterns in the tube. An interesting feature of a kaleidoscope is that you will never see the same pattern again. Designers of wallpapers and fabrics and artists often use kaleidoscopes to get ideas for new patterns. To make your toy attractive, you can wrap the kaleidoscope in a color paper. So these are what about the making of a kaleidoscope. So when we peep through the hole, then we will be able to see a variety of patterns in tube. So this is an interesting feature of a kaleidoscope, and that you will never see the same pattern again. So designers of wallpapers and fabrics and artists often use kaleidoscopes to get ideas for new patterns, so to make your toy attractive. So activity 16.7, let's see what it says. Get a plain mirror of a suitable size. Place it in a bowl that is called what? Katori. It is Hindi, as shown in figure 16.13. Fill the bowl with water. Put this arrangement near a window in such a way that direct sunlight falls on the mirror. Adjust the position of the bowl so that the reflected light from the mirror falls on a wall If the wall is not white, fix a sheet of white paper on it. Reflected light will be seen to have many colors. How can you explain this? The mirror and water form a prism. As you learn in class 7, this breaks up the light into its colors. Splitting of light into its colors is known as dispersion of light. So, dispersion of light is a term in which the splitting of light into its constituent colors, that is called dispersion of light. So, rainbow is a natural phenomenon showing dispersion. So, in the rainbow, we can see different colors of light. So, that is one example of dispersion of light. So here, dispersion of light, figure number 16.13, we can see the spectrum of light, different colors of light we can see here. Now let's continue. Next, page number 231, what it says, let's see. This textbook page number 230. Sunlight, white or color? Sunlight is white or color. Let's see. In class 7, you learned that the sunlight is referred to as white light. So from class 7, we have learned that sunlight is white light. You also learned that it consists of 7 colors. Here is another activity 16.7, showing that sunlight consists of several colors. So, sunlight is considered to be the white light. It consists of different colors of light of different wavelengths. So, next, what is inside our eyes? We see things only when light coming from them enters our eyes. So eye is one of our most important sense organs. It is therefore important to understand its structure and working. So human eye is one of the important sense organ. We can see the objects around us by our eyes. So how can we see the objects around us? When the light ray falls on the objects, and some parts of the light energy reflected back from that object, and it reaches on our eyes and images formed in the retina. Thus we can see objects. So the eye has a roughly spherical shape. The outer core of the eye is white, and it is topped so that it can protect the interior of the eye from accidents. Its transparent front part is called cornea. Transparent front part is called cornea. Figure number 16.14 we have seen here. Behind the cornea we find a dark muscular structure called iris. In the iris there is a small opening called the pupil. The size of the pupil is controlled by the iris. The iris is that part of eye which gives it its distinctive color. When we say that a person has green eyes, we refer actually to the color of the iris. The iris controls the amount of light entering into the eye. Let us see how. So these are the different parts of the eye. We can see here the structure of the human eye is shown in the textbook, figure number 16.14. Let's see. This is the human eye. Then this is the lens. Lens is here. Then it is iris. Ciliary muscle is shown here, and cornea is shown here. This is the optic nerve, and this is retina. So, caution. For this activity, not use a laser torch. Never use. For this activity, you should never use a laser torch. So, let's see. Activity 16.I. Look into your friend's eye. Observe the size of the pupil. Throw light on her eye with a torch. Observe the pupil now. Switch off the torch and observe her pupil once again. Do you notice any change in the size of the pupil? In which case was the pupil larger? Why do you think it was so? In which case do you need to allow more light in the eye when the light is dim or bright? So we have to look into your friend's eye and you observe the size of the pupil and throw light on her eye with a torch. And we can observe the pupil now. And you switch off the torch and observe her pupil once again. So we can notice any change in the size of the pupil. So in which case was the pupil larger? And why do you think it was so? So in which case do you need to allow more light in the eye when the light is dim or bright? So this is an activity. So behind the pupil of the eye is a lens which is thicker in the center. And what kind of lens is thicker at the center? So recall what you learned about lenses in class 7. The lens focuses light on the back of the eye on a layer called retina. Figure number 16.14. The retina contains several nerve cells. Sensations felt by the nerve cells are then transmitted to the brain through the optic nerve. There are two kinds of cells. So, retina contains two sensitive cells. They are rods and cones. So let's study one by one. Here, first cones. Cones, which are sensitive to bright light, and number 2, rods, which are sensitive to dim light. Cones sense color at the junction of the optic nerve and the retina. And there are no sensory cells, so no vision is possible at that spot. So this is called the blind spot. So its existence can be demonstrated as follows. So here, activity 16.9, let's see. Make a round mark and a cross on a sheet of paper with a spot to the right of the cross. Figure number 16.15. Let's see. The distance between two marks may be 6 to 8 centimeters. Hold the sheet of paper at an arm's length from the eye. Close your left eye. Look continuously at the cross. Move the sheet slowly towards you, keeping your eye on the cross. What do you find? Does the round mark disappear at some point? Now close your right eye. Look at the round mark now and repeat the activity. Does the cross disappear? The disappearance of the cross or the round mark shows that there is a point on the retina which cannot send messages to the brain when light falls on it. So here we can see demonstration of the blind spot. Here a cross mark is here and dark mark is shown here. So from this activity you have to look continuously at the cross and move the sheet slowly towards you and keeping your eye on the cross. And what do you find? And thus the round mark disappear at some point. And now you can close your right eye and look at around the mark and repeat the activity. And thus the cross disappear, and the disappearance of the cross or the round mark shows that there is a point on the retina and which cannot send message to the brain. So this is an activity. Next page, let's see. Page number 232, let's see. Here, the impression of an image does not vanish immediately from the retina, and it persists there for about 1 to 16 of a second. So, if still images of a moving object are flashed on the eye at a rate faster than 16 per second, then the eye perceives this object is moving. So the impression of an image does not vanish immediately from the retina, and it persists there for about 1 by 16 of a second. So if a still image of a moving object are flashed on the eye, then at a rate faster than 16 per second, then the eye perceives this object as moving. So here, activity 16.10, let's see. Activity 16.10, what it says. Let's see. Here is activity. So, get a square piece of cardboard of size 6 to 8 centimeter. Make 2 holes as shown in figure 16.16. Thread a string through the 2 holes. Draw or paste a case on one side of the cardboard and a bar on the other side. And twist the string and make the card twirl rapidly. Do you see the bar in the case? So you should try to get a square piece of cardboard of size 6 to 8 centimeter, and we have to make 2 holes as shown in figure 16.16. So thread a string through the 2 holes and draw or paste a case on one side of the cardboard and a bar on the other side. So here we have to twist the string and make the card twirl rapidly. Now, do you see the bar in the case? So here, figure 16.16, bar in case. Let's see. This is the bar and this is the case. So front side of cardboard is shown here and reverse side of cardboard is shown here. So this is, for this activity, we have to draw or paste a case on one side. So the movies that we see are actually a number of separate pictures in proper sequence. So they are made to move across the eye, usually at the rate of 24 pictures per second. So 24 pictures per second, that is faster than 16 per second. So we see a moving picture here, we can see. Then nature has provided eyes. So nature has provided human eyes with eyelids to prevent any object from entering the eye. So even human also and some other animal also, in the eyes, eyelid is there, so it prevent any object from entering the eye. That may be dust particle or any foreign particle entering the eye is protected by eyelids. So eyelids also shut off light when not required. So eyelids also shut off light when not required. Eyelid also shut off light when not required. Then eye is such a wonderful instrument that it normal can clearly see distant objects as well as objects nearby. The minimum distance at which the eye can see objects distinctly varies with age. The most comfortable distance at which one can read with a normal eye is about 25 centimeters. So, eye is such a wonderful instrument that it normally can clearly see distant objects as well as objects nearby. So, here we can say the minimum distance at which the eye can see objects distinctly varies with age. So, the most comfortable distance at which one can read with a normal eye is about 25 centimeters. So, for a healthy person, healthy eye, there is no any vision defect. For those people, the less distance for distinct vision is 25 centimeter. 25 centimeter is the less distance for distinct vision is 25 centimeter. And for the difference of the age, the less distance of the distinct vision may vary because of the difference of the age. So, let's see, for the healthy person, healthy eye, the far point of distinct vision is infinity. So here, some persons can see objects close to them clearly, but cannot see distant objects so clearly. On the other hand, some persons cannot see objects nearby clearly, but they can see distant objects quite well. So, with suitable corrective lenses, these defects of the eye can be corrected. So, some persons can see objects close to them, see clearly, but cannot see distant objects so clearly. On the other hand, some persons cannot see objects nearby clearly. Some persons cannot see objects nearby clearly, but they can see distant objects. But they can see distant objects quite well. So, with suitable corrective lenses, these defects of the eye can be corrected. So here, what defect of the vision? Defect of the vision can be corrected by using suitable corrective lens. So thereby, what we say, because of the difference of the age, most of the people they suffer from defect of vision. So that defect of the vision can be corrected by using lens. So here, let's continue. Sometimes, particularly in old age, eyesight becomes foggy, and it is due to the eye lens becoming cloudy. And when it happens, the persons are said to have cataract. There is a loss of vision, and sometimes extremely severe, and it is possible to treat this defect. The opaque lens is removed and a new artificial lens is inserted. Modern technology has made this procedure simpler and safer. So modern technology has made this procedure simpler and safer. So sometimes, particularly in old age, eyesight becomes foggy, and it is due to the eye lens becoming cloudy. And when it happens, then persons are said to have cataract. So this is a loss of vision. Cataract is also a loss of vision and sometimes extremely severe, and it is possible to treat this defect. So the opaque lens is removed and a new artificial lens is inserted. So modern technology has made this procedure simpler and safer. So in this modern technology, this problem of cataract can be solved by procedure simpler and safer. So how to take care of the eyes? Let's see. Care of the eyes. Let's see. Care of the eyes. Let's see. How can we take care of our eyes? You know, our eyes is one of the most important organ. We can see the things around us by means of our eyes. So let's see. It is necessary that you take proper care of your eyes. If there is any problem, you should go to an eye specialist. So it is necessary that you take proper care of your eyes. You can take proper care of your eyes, and if there is any problem, then you should go to an eye specialist. There is ophthalmologist. So you have a regular checkup. So if we have any problem for our eyes, then we can consult with eye specialist, that is ophthalmologist, for regular checkup. If advised, then use suitable spectacles. If advised, then use suitable spectacles. So too little or too much light is bad for eyes. Insufficient light causes eye strain and headache. So too much light, like that of the sun. A powerful lamp or a laser torch can injure the retina. So here we can see care of the eyes. It is necessary that we take proper care of our eyes, and if there is any problem, then you should go to an eye specialist. We should go to an eye specialist if we have any problem. So we have to do a regular checkup. So if advised, then we should use suitable spectacles. If the ophthalmologist advised, then we should use spectacles. And too little or too much light is bad for eyes. So proper or sufficient light, insufficient light causes eye strain and headache. So too much light, like that of the sun, that is a powerful lamp or a laser torch, can injure the retina. And do not look at the sun or a powerful light directly. So do not look at the sun. So we should not look at the sun or a powerful light directly. Never rub your eyes. You should never rub your eyes. If particles of dust go into your eyes, wash your eyes with clean water. If there is no improvement, go to a doctor. So we should not look at the sun or a powerful light directly. So never rub your eyes. You should never rub your eyes if particles of dust go into your eyes. If particles of dust go into your eyes, then you should wash your eyes with clean water. If there is no improvement, If there is no improvement, then go to a doctor. You have to go to a doctor. And always read at the normal distance for vision. So we have to always read at the normal distance for vision. Do not read by bringing the book too close to your eyes or keeping it too far. So always read at the normal distance for vision. Normal distance for vision, and do not read by bringing the book too close. We should not bring the book too close to our eyes or keeping it too far. That is not good for our eyes. And you learn about balanced diet in class 6. In class 6, we have learned about balanced diet. If food is deficient in some components, then eyes may also suffer. So lack of vitamin A in food stuff is responsible for many eye troubles. So lack of vitamin A in food stuff. Lack of vitamin A in food stuff is responsible for many eye troubles, and most common amongst them is night blindness. And one should therefore include in the diet components which have vitamin A. So vitamin A is very good. We should take proper vitamin A, and which can enhance the performance of the cells that are present in the retina, that are rods and cones. So raw carrots, broccoli, and green vegetables such as spinach and cod liver oil are rich in vitamin A. Eggs, milk, curd, cheese, butter, and fruits such as papaya and mango are also rich in vitamin A. So these are the food items that contain more quantity of vitamin A. So before we proceed, now let's see some points. Did you know these points? Let's try to learn. Animals have eyes shaped in different ways. Eyes of a crab are quite small, but they enable the crab to look all around. So the crab can sense even if the enemy approaches from behind. Butterflies have large eyes that seem to be made up of thousands of little eyes. Figure number 16.17, let's see. They can see not only in the front and the sides, but the back as well. So they can see not only in the front and the sides, but the back also they can see, butterfly. So a night bird, that is owl. Owl is also known as the night bird because during the nighttime the owl can see. So can see very well in the night, but not during the day. So owl cannot see during the day, but owl can see during the night time. So on the other hand, daylight birds like say kite, eagle, can see well during the day, but not in the night. So during the daytime they can see very clearly, but not in the night. The owl has a large cornea and a large pupil to allow more light in its eye. The owl has a large cornea and a large pupil to allow more light in its eye. So, you know, owl also has a large cornea and a large pupil to allow more light in its eye. And also it has on its retina a large number of rods and only a few cones. The day birds, on the other hand, have more cones and fewer rods. You know, the day birds on the other hand have more cones and fewer rods. So here we can see figure number 16.17, eyes of a butterfly. Here the eyes of a butterfly we can see here. So now let's continue. If visually impaired persons can read and write, how they can read and write, let's see. Some persons, including children, can be visually impaired. They have very limited vision to see things. Some persons cannot see at all since birth. Some persons may lose their eyesight because of a disease or an injury. Such persons try to identify things by touching and listening to voice more carefully. They develop their other senses more sharply. However, additional resources can enable them to develop their capabilities further. So, these are what about the visual impaired person. They can read and write. And now let's continue. Page number 234. Here, non-optical and optical aids for visually impaired. Let's see. Non-optical aids include visual aids, say textual aids using the sense of touch, auditory aids using the sense of hearing, and electronic aids. So visual aids can magnify words and can provide suitable intensity of light and material at proper distances. Textual aids, including braille writer, slate, and stylus, help the visually challenged persons in taking notes, reading and writing. Auditory aids include cassettes, tape recorders, talking books, and other such devices. Electronic aids, such as talking calculators and computers, are also available for performing many computational tasks. Closed-circuit television, also an electronic aid. Enlarged printed material with suitable contrast and illumination. Nowadays, use of audio CDs and voice box with computers are also very helpful for listening to and writing the desired text. So, optical aids include bifocal lenses, contact lens, tinted lenses, magnifiers, and telescopic aids. So while the lens combinations are used to rectify visual limitations, telescopic aids are available to view solveboard and class demonstrations. Now, these are what about the non-optical and optical aids for visually impaired. Then, what is the Braille system? Now, let's see. Braille system. The most popular resource for visually challenged persons is Braille. Now, let's see what is Braille. What is Braille? Then, Louis Braille, himself a visually challenged person, developed a system for visually challenged persons and published it in 1821. So, Louis Braille. Now, let's see Louis Braille. The present system was adopted in 1932. There is Braille code for common language, mathematics, and scientific notation. Many Indian languages can be read using the Braille system. So here, Braille system has 63 dot patterns or characters. Each character represents a letter, a combination of letters, a common word, or a grammatical sign. Dots are arranged in cells of 2 vertical rows of 3 dots each. Patterns of dots to represent some English letters and some common words are shown below. Here we can see CAT. So the representation of the dot is it is shown here, and comma. It is shown here like this. So this figure number 16.1i, examples of dot pattern used in Braille system. Now, these patterns, when embossed on Braille sheets, help visually challenged persons to recognize words by touching to make them easier to touch. The dots are raised slightly. Visually impaired people learn the Braille system by beginning with letters, then special characters and letter combinations. Methods depend upon recognition by touching. So each character has to be memorized. Braille text can be produced by hand or by machine. Typewriter-like devices and printing machines have now been developed. So, some visually impaired Indians have great achievements to their credit. So, Diwakar, a child prodigy, has given amazing performances as a singer, and Rabindra Jain, born completely visually impaired, obtained his Sangeet Prabhakar degree from Allahabad. He had shown his excellence as a lyricist, singer and music composer. Lal Advani, himself visually impaired, established an association for special education and rehabilitation of disabled in India. Besides this, he represented India on viral problems in UNESCO. So Helen Keller, picture is shown here. So Helen Keller, an American author and lecturer, is perhaps the most well-known and inspiring visually challenged person. She lost her sight when she was only 18 months old. But because of her resolve and courage, she could complete her graduation from a university. She wrote a number of books, including The Story of My Life, 1903. So, this book written by Helen Keller. So, she is an American author and lecturer and is perhaps the most well-known and inspiring visually challenged person, and she lost her sight when she was only 18 months old. So, but because of her resolve and courage, she could complete her graduation from a university, and she wrote a number of books, including The Story of My Life. So, The Story of My Life, this book she wrote in 1903. So, with that, it comes to the end of this video class. In the next video class, let's study a new chapter. For today, bye.